Intro Algebra Lesson 5-3b. Last time we were going over the concept of being able to write an equation when only given two coordinates. So we're still going to look at that. These are just a recap from last time. First thing we want to do is find the slope from the two coordinates using the slope formula, probably the easiest way. Next we use that newfound slope and one of the coordinates. Again, it doesn't matter which one of the coordinates you choose, just pick one of them. Use the slope and one of those coordinates. That will allow you to solve for b. Once you have the b and the m, you can now write your equation y equals mx plus b. So it's really pretty easy. Now, I'm going to twist it a little bit. We've talked in the past about when lines are parallel. When lines are parallel, we know that the slopes are identical. They have exactly the same slope. Today, we're not going to talk about parallel lines, so the slopes will not be identical. They'll be slightly different. All right? This is what we call perpendicular lines. Lines that are perpendicular will cross and form a 90-degree angle. So this is not considered perpendicular. They are crossing, but they're not crossing at 90. This would be considered perpendicular because they're crossing at 90. It doesn't matter where. These are still perpendicular lines if they are crossing at 90. All right? So if the lines cross and form a 90-degree angle, that's considered perpendicular. Now let's talk about their slopes. The slopes are negative, or negative is another way of saying opposite, and reciprocal is when they flip slope. So if I were to tell you that this slope right here went up 1 and right 1, it would be a positive 1 over 1. In order to be perpendicular, it's going to have to be negative because it must go the opposite direction. When it goes up from left to right, it's positive. When it goes down from left to right, it's negative. So if this is positive 1 over 1, then this is going to be negative 1 over 1. It's going down 1 and right 1. Down 1, right 1. This one goes up 1 and right 1. This one goes down 1 and right 1. They are opposite reciprocals of each other. So as a couple examples of opposite reciprocal, imagine here that we had one line that had a slope that was 1/2. So that means it goes up 1 and right 2. The perpendicular, this is the symbol for perpendicular, the perpendicular line is going to be the reciprocal of this. In other words, it's going to flip. That's why it's now 2 over 1. But it also has to be opposite. So the opposite of 1/2, or the opposite of positive is negative, becomes negative 2 over 1. Some very common mistakes. People will make it just the negative. They won't actually flip it with the reciprocal. They'll just say, oh, the perpendicular line is negative 1/2. Or another mistake is they reciprocate it, but they forget to change the sign. So let's just come up with I'm just going to write a few. Here's 3/4, negative 5/8, and 2/3. Okay, and we want to know what's perpendicular to each one of these. So here is a positive. That means perpendicular is going to have to be negative, and you have to flip it. All right? It won't matter if you put the negative on top or bottom, just as long as one of them is negative. Okay, this one's negative, so the perpendicular is going to have to be positive, and I flip it. So there we have it. This one down here is positive, so the perpendicular is going to have to be negative, and we flip it. So we could say negative 2, oops, I didn't flip it, negative 3 over 2. So if I tell you the slope of one equation, and I tell you that your equation is perpendicular, you know to look at the one equation, flip it and change the sign. Flip it and change the sign. Flip it and change the sign. That's what you have to do when you're dealing with perpendicular lines. So here, given this scenario, we want to know if in this graph, if line segment F to G, which is here to here, is perpendicular with G to H. So what I'm going to need to do is I'm going to have to figure out, well, what are the slopes? Well, the slope from here goes up 1, 2, 3, 4, 5, 6, and left 1, 2. So it goes up 6, but left 2. So as far as the slope for GH, GH has a rise of 6 and a run of negative 2. The other one goes up 1, 2, 1, 2, 3, 4, 5, 6. So it goes up 2 and a run of positive 6. So now the rise for the F to G, the rise was 2 and the run was 6. And so if you look at the two, they are definitely opposite because this one's positive and that one's negative, and they seem to be reciprocals of each other. So this is the opposite reciprocal. So are they perpendicular? The answer would be yes. They are perpendicular to each other because the opposite reciprocal slopes. This one went up 6 and left 2. This one goes up 2 and right 6. So the slopes are opposite reciprocals. So what's happening is this is actually forming a right angle. Now, in order to write equations for each of those lines, FG, or line segment FG and GH, we start off with FG. We already know its slope is 2 over 6, which, by the way, 2/6 simplifies down to 1/3. So we can use either one of those forms if we'd like. It's very difficult to look at the graph and say, oh, that's the y-intercept. But we do have a couple coordinates. This coordinate right here is on F to G, and it goes over 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that's actually the coordinate 4, 6. So I can use this information, my slope and a point. I can substitute it in and I can find the exact value of the y-intercept. For G to H, for line segment G to H, we now know the slope is the opposite reciprocal, which means it's going to be negative 6 over negative 2, which is the same thing as negative 3 over 1, or negative 3, because I can divide each of these by 2. And I can use the exact same coordinate 4, 6, because 4, 6 is on the same line. If I wanted to, I could use 7, 0. It doesn't matter, whichever one. Okay? Start with GH, since it's on the right side of the screen and I can work my way this way. In y equals mx plus b, I'm going to have an x and a y right there, so 6 equals my negative 3 for a slope times 4 plus b, which means 6 equals negative 12 plus b. We can add 12 to both sides. And we end up with 18 equals b. That means my y-intercept for GH is at 18. Let's take a look at that. Right now, that line keeps on going, and the idea that it's going to cross somewhere up here on the x-axis. Now that's 10. 11, 12, 13, 14, 15, 16, 17, 18. Does it seem reasonable that it could cross up there at 18? I believe so. I think our math is done correctly. So when it comes to writing our equation, we know the slope is negative 3. So we can say y equals negative 3x plus 18. And there we have our equation for line GH. Very similar process, but for F to G. So now we're going to say this is x, this is y. We're using y equals mx plus b once again. So we'll go 6 equals 1/3 times the 4 plus the b. You might want to make 4 as a fraction, so now you have 6 equals 4/3 plus b. And now you have to get the 4/3 out of here so you can solve for b. So you add negative 4/3 to both sides. Now this is a little tricky. Negative 4/3 is actually negative 1 1/3. So when you're thinking about adding negative 1 1/3 to 6, you have to be careful about that. You actually come up with 4 2/3. Well, let's look at the graph. Here is 1, 2, 3, 4. It's not quite 4 and it's not quite 5. It appears to be a little closer to 5. That means that our answer of 4 2/3 for a b value seems reasonable. So we would say y equals, our slope, remember, was 1/3 x plus 4 2/3. If I want to make it an improper fraction, I can either use the 4 2/3 or I can go that's 14/3. Either way, this is the same as 14/3. So there we have the equations. It's still based on the same concept as before, where we use the two coordinates to find the slope, or we can count them on the graph, and we go from there.